Hello everybody, Sandeep here. Welcome to our channel Econstruct Design and Build Private Limited. In this particular video, we are going to discuss about the foundation engineering. Whenever any structural engineer or a structural consultant is dealing with the foundation of a particular structure, he has to carry out many different checks. One is basically the soil testing related to the geology, related to the soil mechanics, related to the hydrology, means how much amount of water is there below the earth surface, related to the type of soil, whether it is a sandy soil, whether it is a cohesive soil, whether it is murum, whether it is a rocky. So what kind of soil mechanism and the sedimentary or certain types of rocks are there below the earth's surface, that is very important, and that generally we get it from the geotechnical soil investigation report. As a structural engineer, this particular report is extremely important for you to know. Along with that, as a structural engineer, you require to know the superstructure and the substructure interaction, means the soil structure interaction. Related to the foundation, you require geology, geotech, hydrology, neighboring structures, superstructure analysis. Different types of analysis are there. Like for example, linear, non-linear. Soil is considered to be the completely non-linear type of analysis. For example, if you press your leg onto the soil will start resisting it. But the moment you are taking out the leg from a particular soil surface, the soil will not say, "Oh my dear leg, where are you going?" It means that the soil is good in terms of the compression, but in terms of tension, it's not good. It's not the linear behavior. It is a completely non-linear behavior. Unfortunately, in the Terzaghi equations and many different equations, these things are not being taught to us. Right, so it is very important from the structural engineering point of view how to analyze the soil parameters or the soil structure interaction, considering the non-linearity of the soil into consideration. For example, compression, there is a full-fledged compression. At the same time, the compression means like a spring. If you take any railway or two-wheeler or four-wheeler, you will see that if the undulation of the surface is there, you will see that the spring or the shock absorbers are there. It gives you the comfort level. Similarly, the soil also during the earthquake engineering or differential forces transfer, it gives you the cushioning effect, which we call it as the spring. So line spring, point spring, area springs, different spring patterns are there when it comes to the soil. Okay, so these kind of parameter. What is the spring? Spring value is basically, you take a ball pen like this, you will see that the force divided by the displacement is the spring. Force upon area is the stress. Force upon displacement is the spring value. So point load divided by the point displacement, how it is going down, which is generally considered in the pile foundation, it is considered to be the point spring. Line spring comes where you will be having the grade beam on the soil, which is the beam which is resting directly onto the soil. That is basically, we call it as the line spring. Area springs are isolated footings, combined footing, raft. This comes under the area springs. So area spring means what? The aerial load which is coming onto this divided by how much the entire area is getting settled. Many a times what happens generally in the foundation engineering, you will not have the exactly same amount of load onto the columns. Individual columns will have separate loads. So how do you analyze it? How do you check it? This type of analysis need to be considered, because more the load, more will be the settlement. Obviously, the more settlement, actually the spring values will change. And unfortunately, even till today, we are considering most of the areas SBC of the soil as well as the spring constants. These two parameters, even today we are considering it, which is not the legitimate good parameters. Nowadays, there are so many different mechanisms are there where you can do the relativity study, non-linear study, performance-based study. Based on that, you can exactly find out the spring constants, and based on that, you can analyze the project. Such kind of projects, such kind of parameters, if you take it into consideration, I am sure that you will be saving quite a lot of money, and basically your foundations will be perfectly done. Many a times people, let's say ETABS or StatPro or MIDAS, this kind of software, people are doing that these softwares are enough even to design the foundations. No. If you say the CSI, in the CSI software, there is particular software, we call it as SAP 2000 or ETABS, and there is another software, we call it as SAFE. Without SAFE, the generally foundations are not safe, because one structure is resting on the another. Actually, you are giving the fixed support in the mathematical model in the ETABS or SAP 2000, and From there, you are asking the structure, you give whatever the loads are there, you give the fixed supports, means the infinity stiffness there, and based on those loads, now you are giving the that particular loads to the foundation. So that's how the interaction doesn't happen during the phase of analysis, and that you do it after the analysis. That's why we require the foundation. For designing the foundation, we require the SAFE as a mainstream software. If you take the CSI software, you will see that ETABS and SAP 2000 is for the superstructure, whereas for the substructure you will have the SAFE. Another thing is, if you go to the STAD or the CA or the Bentley as a platform, you will see that the software which is for the superstructure, that is STAD Pro. For the substructure, there is a STAD Foundation. Similarly, if you go to the Midas, there is a Midas Jain, Midas Civil for the superstructure, and Midas SJS, which we call it as for the substructure. So like that, different softwares are created, particularly focusing the area of what exactly you require as a part of the structural engineer. These kind of disciplinary knowledge, this kind of software expertise, you really require to acquire if you want to become the structural design engineer or a consultant. This is a fabulous branch of the civil engineering, and very proudly you will say that I'm a structural consultant. I generally, design in our particular company, unlimited, I am having unlimited license in Mumbai, up to Z+6 to 70-story building also we are designing. I am sure that you guys, once you come to our company, we will give you a lot of expertise and the knowledge related to this. Thank you so much. See you in the next video. Bye-bye.